YouTube. Welcome back. Today, or this hour, we're going to try to go through a concept called inclusion exclusion. This class is called Math 32 Probability and Statistics. I suspect that most of you have been taught some techniques in statistics before, such as finding a mean, median, or standard deviation. So, what I want to do early in the semester is to actually start off on probability, show you some material you might not have seen before to just kind of get things going in a more intellectually stimulating way. Admittedly, when I ran these classes in person, the slideshows made a bit more sense. And I'm not going to full screen this because I'm going to switch over to something else in just a second. But let's go ahead and read through this example. So, when we're going over probability concepts, it's usually best in a classroom setting to start off in a very simple setting. Admittedly, it's tedious, it can be boring, but I found it's best to start off with easy examples and then work our way up to tough examples. So, as you can see, I'm going to frequently refer to rolling a six sided die. Now, in our mathematical notation, what you're going to see is that the people who work with probability, tend to use capital letters to describe what are called events. So we're going to let capital A be the event of rolling an even number. We're going to let capital B be the event of rolling a number that is greater than 3. And, oh, yeah, that's supposed to be there. And capital C be the event of rolling a double digit result. And then we'll do what are called compound calculations such as A or B. I don't have a whiteboard at my disposal. Actually, I do have a whiteboard at my disposal, but I think it might be better to avoid my awful handwriting. And let me see if I could make an Excel document instead. Yeah, a lot of my colleagues do not like my mechanical keyboard. That's why I'm almost always muted on Zoom. Alright, so we have what's called a sample space. And here our sample space is simply listing the numbers 1 through 6. We're going to say that event A, the event of rolling an even number, is of course the numbers 2, 4, and 6. That's the subset. And then we say that the probability of A would be those 3 elements in subset A divided by the number of elements in the entire set, namely 3 out of 6. You'll also notice that as I'm going along through these examples, I do not simplify my fractions. In Math 32 or in other statistics classes, I ask my students to not reduce their fractions because when I ask my students to take on the skill of going from a word problem to the calculations. And it's actually easier for us to grade your work if the fractions are not reduced. There are a couple people in chat talking about ASMR. I don't know if I should admit I know what that is or not. Okay, so capital B is the event of a number greater than 3, which will be the 4, 5, and 6. Probability of B is again 3 out of 6 numbers. Capital C would be a double-digit result. Intentionally ask a question that is silly here. If you roll one die, what's the probability that the number will be a 2-digit number? Whoops. Autocorrect there. And the probability of C is 0. So now I'm going to try to be clever here. We're going to ask, what's the probability A or B? So in words, that's just saying, what's the probability of rolling an even number or rolling a number greater than 3? Perhaps this is a good time to color code things. Let the numbers in event A have a red color here. So that's this one, and this one. Give the numbers in event B a blue background. So that's these 3 here. And folks in chat, guided by what we see on screen, understand where this is headed. But just to play devil's advocate, let me take you through a little bit of math history. When mathematicians started to ask, what is the probability A or B? Does this show up on screen? Damn. Sorry, the area where I'm typing in the top right might not be that visible, but it'll appear at the bottom in just a second. So the way they started to ask to do that probability is, well, you could take the probability A plus B. But what we just discovered is that the probability A was 3 out of 6. The probability of B was 3 out of 6. So at the moment, this calculation implies that the result is 100%. But as you can plainly see, for the colors or the numbers that I've color coded in red or blue, we did not highlight all the numbers. So there's a bit of a discrepancy here. So let me take a verbal break, ask the people in chat what happened, what went wrong. The question in chat is, why are we not reducing the numbers? It's literally just because later on it makes it easier for us grading your homework if the numbers are not reduced. I'm more concerned about if you know what numbers to put where, rather than if you can reduce the fractions. So as the folks in chat correctly pointed out, the numbers 4 and 6 were represented twice. there is a bit of an overlap. And this is called the intersection. Maybe it should have go there. So for the intersection, we have the numbers 4 and 6, like you correctly noted. Thus, the probability for that intersection is 2 out of 6. But what we're doing right now with the OR statement is called a union. A or B is a union of these sets. And as you probably guessed by now, the step that we need to take is that if some numbers were counted twice, we need to compensate for that. And the way we're going to do that is by subtracting one copy of that overlap, of that intersection. So this starts off, so the numbers are small at the moment, they'll appear at the bottom of the screen in just a second. So this starts off the same way, 3, 6 plus 3, 6, but then we subtract the two numbers that were counted twice. And that will get us the 4 numbers that we had highlighted in the first place. So this formula here is called the inclusion-exclusion principle. A needlessly complicated name for just making sure that we understand where the elements of the sets are and doing a compensation just in case something got counted twice or multiple times. The folks in chat seem pretty confident about this material. I'm glad. Let's go ahead and then kick this up to a slightly more difficult setting. We're going to consider rolling a pair of dice this time. So we're going to have, let's see if I could get clever with some things here. We're going to have a sample space that is actually this grid, 6x6, 36 possibilities. And as if you were playing a board game, we then add up the dice. So give me a minute to fill this in. Like so. I hope you all really like typing as much as I did. So this time around, we're going to let A be the event that the total is 8, and B be the event that the second die is greater or equal to 5. One of the reasons I like the whiteboard is the color coding. So once again, I'm going to try to color code this. Event A, total is 8. That is these 5 places here. Now for event B, we'll go ahead and do the light blue background again. The wording is a bit awkward. I don't really consider it to be a big deal at the moment. It's just for the sake of showing an example. I'm going to assume that the second die is here on the left. And when I say that the number is greater or equal to 5, then that could be either of these two rows here. And thus, the possibilities would be these two rows. So now, if we ask the question again, what's the probability of A or B? We're going to be careful about the way we count these elements. Probability A plus the probability of B minus the overlap. There's a request for repeat here. I defined event B to be these words here. The second die shows a number greater or equal to 5. Going down this column, these two numbers are greater or equal to 5. And thus, amongst the 36 probabilities, they are expressed in these two rows. So in the probability A, I'm literally counting the red 8s. That's 5 out of 36. The probability of B, we have those 12 out of 36 that were highlighted, that I have in the blue highlights. You'll notice another offshoot of why I asked you not to reduce their fractions is because now you have the common denominator. But you'll notice that we have an overlap. These two places, Excel got a bit ugly there. These two places are overlapping in their descriptions. They got counted twice. So we have to compensate by subtracting one copy of the overlap. And thus, as the folks in chat correctly surmised, the answer is 15 out of 36. So another question that came up in the chat is, well, how did we get to here from the word problem? It's actually this or. That or there gets translated into math speak to this or here. That or leads to this formula, the inclusion-exclusion principle. So as we proceed through the semester, you'll notice me giving you these hints. I want you to be able to handle word problems that talk about probability, and the skill is to try to dissect these word problems, looking for these signal words. So the topic today focuses on the word or. If we see the word or, we might be using this inclusion exclusion formula. And just to flip back to the previous slide, I did have the word or there. That went over a little better than I thought it would. Fortunately, I forget what the rest of my slides were. Alright, just for a little bit of jargon, alas, this being a sophisticated math class, most of my lectures will start off with about 5 or 10 minutes of jargon or definitions or whatnot. So one quick definition is that we say two sets are disjoint. Two sets are disjoint if the probability of their intersection is 0. Probably sounds simple enough once you think it through. So the way this works out is if we just happen to have a situation where the sets are disjoint, where there's no overlap to worry about, then the formula becomes much simpler. We don't have to worry about the overlap. We don't have to subtract the overlap. The question in chat is this the same thing as mutually exclusive? I think it is, yes. I think it's the same definition as mutually exclusive. This is one of those events where I state something that sounds ridiculously obvious, but the reason why I'm taking this on right now is because we're going to refer to this result later in the semester. The question in chat is about the YouTube uploads. I'm going to try to upload the videos between 5 p.m. and 5:30 every day. So I tell myself each semester that I'm going to try to create demonstrations that will further elucidate the ideas. Let me just double check what the rest of my slides are. Okay. So I do have a demonstration here called inclusion exclusion. The link, as you can see, is already in the slide. So in case you wanted to try out this app yourself, you can. I write these apps in the R programming language in a framework called Shiny. Sorry, it's just taking a bit for the website to load. I actually write your SHW assignments in the same framework as well. So the wrong window. See if I could get the text sizes a little bit bigger. So what the program does is at first it creates two randomly sized rectangles. I'm just going to refresh it a few times so I can see that. And the sliders on the left literally let you move the red and green rectangles around. Let me see if I get two different shapes there. There we go. So I happen to have red in for letter A and blue for or green for rectangle B. You could play around with this app and get a sense of these probabilities. So as you can see, there is a number for probability of A, there's a number for probability of B. At the moment, the probability A and B, the probability of being in the intersection is 0. And you could plainly see that the rectangles are not overlapping. But now, when I put the rectangles back together, now you can see that there is a bit of an overlap. Putting the rectangles apart, the probability A or B in this randomized example just happens to be about 0.0864. If I completely engulf the small rectangle in the big rectangle, I think I can. Maybe not quite. Let me see if I can get a different picture. There we go. So in this picture, when the two rectangles are separate, the probability A or B is about 0.0433 here in the top right. Sorry, didn't quite get the result I wanted. But nevertheless, you could probably see what I was trying to drive at. That these calculations would be carried out depending on how much the shapes overlap. Alright, so let me take a verbal break here. Oops. And see if there are any more questions from the folks in chat. Just as an aside, I tell people, and this is pretty much true, that my weakness is that I cannot understand mathematics unless I can graph it. I'm a very visual thinker, and you might see that when I teach. I try to graph everything. The question in chat is, how do we handle this calculation over here if we had 3 dice and the folks in chat are correct? We would need some sort of 3-dimensional representation. What would happen is that you would have a bunch of 3-element tuples to wade through, and you would go from there. You would just have a bunch of these 6 times 6 times 6, I believe, is 216 possibilities. The question in chat was, why do the numbers for probability A and B change when I move the rectangles? Honestly, it's because I did not have the app completely programmed correctly. So I was supposed to fix that, and I did not. The probabilities refer to the entire unit square in my app. So you notice on the x-axis it goes from 0 to 1. On the y-axis it goes from 0 to 1. That's a total area of 1 square unit. And again, the framework is called Shiny. It's a framework to make app building easier for novices so that you could combine JavaScript and R pretty quickly. Admittedly, it does not make expert level applications or executables, but it's good when you're just trying to express some information quickly. That's my usual advertisement for the R programming language. It might not be the best programming language, but it's very user friendly. The learning curve is nice, and it's good if you just kind of communicating information to your team, say once a week. If you like need to make a quick informal report by Friday, R is great for that. I'm actually going to move on to some R Studio stuff in just a minute, but let me ask again before I take all this down. Are there any questions about this so far? All right. Let's see. So where am I now? I think I want to go to cat courses. So one of the assignments I'm going to have you do is called Introduction to Markdown. Long story short, when you're a professional, you actually use multiple programming languages. Just in my simple job as a teacher, I probably use about 5 programming languages often. What I want to have you practice is a system called R Markdown. So I'm going to walk you through it right now. Most weeks I'm going to give you a template file to start on. Now, this file format .rmd, it stands for R Markdown. Cat Courses itself does not know how to deal with that file, nor should it know how to deal with that file. You have to explicitly download the file. Unless you are very comfortable with computer stuff, I would recommend on your desktop, make a folder called Math32. Put everything I ask you to download in that Math32 folder. Long story short, if everything for Math32 is in one place, you'll avoid a lot of headaches later. The technical reason is so that we could keep track of the user or the working directory so that we don't have to use relative, advanced relative or absolute links when going between the code and data files. Now that the template file is in your computer, hopefully, if everything else in the installation worked correctly, you could just open the file and RStudio would open up. Now, I'm just going to read this first paragraph off to you. This assignment will introduce you to the R Markdown coding language. Moreover, this R Markdown file, note the .rmd extension, is a setting called literate programming, where a user can alternate between regular typing, enhanced with Markdown, and computer code. Here in RStudio, it's obviously geared towards R. In the near future and in current settings to some ability, you can actually type in Python as well. For those of you who are ready to jump forward into computer programming, you could go straight to RStudio's cheat sheet for R Markdown and figure out what you need. So I'm going to run through this assignment as is I'm a student and go through the questions. So the first task, oh, being a good habit, save often. I'm going to frequently ask you to change the word template to your name, to your full name. It's a teacher trick. If I ask you to type in your name in multiple locations, chances are you'll type in your name in at least one location. So I'm going to also ask you to type in your name here in the author field. The first question, I'm simply asking you for your name, major, and class schedule. Just give a sense of what other classes you're taking, that is. So my name and major is Derek Solberger. I majored in applied math with an emphasis in statistics, and that is true. Now, as you can see, my instructions are a bit anal retentive. I ask you to list your classes, course number, and course name below as an ordered list from the one you think will be the most difficult to the least difficult. Like so. In particular, you'll notice the syntax. I typed in an asterisk and a space. And to be really anal retentive, there's actually a space before this whole group here. And this creates what's called an ordered list. This setting in RStudio, I'm looking at this knit button in the top left. This function in RStudio, what it does is it metaphorically knits the information together. What you typed, the HTML, and maybe a bit of JavaScript as well, into one HTML document, aka a web page. So you're going to knit to HTML, and now this information appears as an ordered list. That is a bullet point list. I probably should have also put another space after my name there. Alright, then to satisfy my curiosity as your teacher, the next question is why are you enrolled in Math 32? But just so I don't get completely bored when reading your responses, please supply an answer that is more in depth than this fulfills my statistics requirement, or it's a major requirement, or something like that. So, something like that. The next task, I'm asking you to tell me a little bit about your knowledge of science. In 2 or 3 sentences, type a science fact that you find fascinating into the code block. So, shoot, probably should have had this known at the top of my head. Something more interesting than that. Now, we'll get to writing R code more and more as the semester progresses, but as you probably surmised by now, this gray rectangle is what's called a code block. It's an environment where the code's supposed to go. Now, at the moment, this is not actually R code, it's just a plain English sentence or two. So I'm going to ask you, or the instructions ask you, to change this parameter to eval equals false. Say, tells RStudio not to evaluate this as R code. And at least just for the sake of practice, you'll notice now this sentence appears in this gray block here. The question in chat is about these parameters. I would not say that they act like a comment, at least not directly. I'm just having you practice with these parameters to hopefully give you a sense of what they do. If you needed to write code comments, there are other ways to do that. So the next part is a psychological exercise. Spend about 5 to 10 minutes typing out the answer to what are your hopes and goals as a bullet point list. Do not worry about grammar, just type fast. Oh, whoops. I meant to make this top one an ordered list. So when you have the numbers like this, 1 dot space, 2 dot space, 3 dot space, that's an ordered list. That produces 1, 2, 3. An unordered list is the asterisk. So one should think about what's important to you and just spend some time just kind of writing out what are your hopes and goals. It's a good psychological exercise. The next one is kind of the opposite. Spend about 5 minutes typing out the answer to what are your fears and obstacles into the code block. Just various thoughts that allow you to kind of expunge your negativity that you might be feeling at the moment. Now you'll notice that the instructions say to set echo equal to false and eval equal to false. So what will happen is that in that space where it says, what are your fears and obstacles, I'm intentionally showing you the code to avoid telling your discussion section leader what are you afraid of. This part here should have a blank answer. Now, this next question made more sense when I had in-person classes. I would try to assemble a class playlist, so when people are entering and exit the class, we would have lively music that was customized for the people in the room. So I asked every student to submit a song that they thought would be great for that playlist. What I furthermore want you to do is, for practice, put the song title in italics with a pair of asterisks, and then put the artist in boldface with two asterisks on each side. Sorry, I'm probably going to go over by about 2 minutes here. Let me go ahead and finish up this process here. So now, this will be your HTML file. This is for some assignments what we're going to be looking at for your work and the grading. You'll notice that Friday by Rebecca Black has the italicized and boldface now. So you'll notice now back in your Math32 folder, a wild HTML file appeared. It's this file that has probably the Safari, Chrome, or Firefox icon. That's the one that I want you to upload back to Cat Courses. So you'll notice in particular, I'm asking for an HTML file. You hit submit assignment. Find that HTML file that's different from your RMD file. I want you to submit the HTML file, and then hopefully everything will work out fine from there. The request is to show how I did that again. Okay. From the RStudio, assuming that there's no errors in the code, you hit the knit button. It creates this HTML file that's now in your Math32 folder. From Cat Courses, when you submit the assignment, you need to find that HTML file in your Math32 folder. As you can imagine, otherwise, most of the homework assignments this week are time-wise on the light side. We want you to get familiar with the mechanisms of how to format your homework and how to upload your homework back to us. That's kind of the big deal right now. Well, we're now over time. I did not plan out a clever conclusion, so I think that's just about it for today, and I will see you on Wednesday.